Hello, welcome to BADM 724 Quantitative Methods and Business Analytics. This is lecture 2. In this lecture, we'll cover an overview of the statistics, why we study statistics, data science, the use of statistics, the pitfalls in using stats, data and level measurements, sampling methods, and survey method. First, an overview of statistics and data science. What is statistics? Why do we study that? Use of that, challenges, and presenting reports and writing reports, critical thinking, and about the evolving field of statistics. Okay? What is statistics? Statistics is the science of collecting, organizing, analyzing, interpreting, and presenting data. It's about data, right? All about data. Some experts prefer to call statistics data science. It's a trilogy of tasks involving data modeling, analysis, and decision making. A statistic is a single measure, is a number used to summarize a sample data set. For example, the average height of students in this class is a statistic. We often say, do not drive carefully, do not become a statistic. That is a statistic, the casualties on highways. A statistician is an expert with at least a master's degree in mathematics or statistics, or a trained professional in a related field. That's called a statistician. Okay? Why do we study statistics and data science? Okay. For one is it helps with communication. Understanding the language of statistics facilitates communication and improves problem solving. Yeah. And also it sharpens your computer skills. The use of spreadsheet like Excel that I was talking to you about previously, using Excel for data analysis and word processors or presentation software for reports, which could improves upon your existing skills. And also statistics helps with the information management. Statistics helps summarize large amounts of data and reveal underlying relationships. And also it helps with technical literacy. A lot of career opportunities are growing in the industries propelled by advanced technology. The use of statistical software increases your technical literacy and your ability to find better future jobs. Also, it's good for your career advancement. Statistical literacy can enhance your career mobility. For you guys, you're all MBA students. You can proudly say that I have taken Dr. Shea's business analytics class. And I'm pretty good at the statistics. And stats is used in quality improvement a lot. Stats can help firms oversee their suppliers, monitor their internal operations, and identify problems. Okay? The use of statistics and data science. There are two primary kinds of statistics, descriptive and inferential. Descriptive stats is the collection, organization, presentation, and summary of data. Right? And the inferential stats is generalizing from a sample to a population, estimating unknown parameters, drawing conclusions, and making decisions. In this class, we'll cover both of them. Yeah. For your for your group presentations, you're going to cover descriptive and inferential stats as well. Okay. So use of statistics, and this chart summarizes statistics, descriptive versus inferential. Right. Over here, you can use stats to collect and describe data, using the sampling and survey methods to collect data, using visual displays to present data, using numerical summaries and probability models to present and describe data. And the second category is making inferences from samples. where you can use the stats to estimate parameters, you can test hypotheses, and you can conduct regression and trend analysis, and use that in quality control. Okay? We'll cover all of this in the later lectures. Okay? I'll give you some examples of uses of statistics. One is auditing and as marketing. For those of you who are majoring in accounting or who have had some accounting courses, you know that, or have been working in accounting or finance, know that there are a lot of invoices, for a company, right? And as an auditor, you are supposed to look over those invoices to make sure the invoice the company sent represents what they actually worked for the client and billed the client. And then based on the invoice, that becomes your accounts receivable. That turns into the money that's coming in. That's your revenue. Right? But to audit a company, you cannot possibly say, the company has over 12,000 invoices. You cannot examine every one of them during the auditing period. What do? You just have to, sample from those invoices to estimate the proportion of incorrectly paid invoices. Right? If the sample shows that they're paid okay, they're correct, then you can reasonably assume that all the invoices are probably paid correctly. Marketing. Right? You can use stats to identify likely repeat customers for Amazon.com, for example, and suggest co-marketing opportunities based on a database of 5 million internet purchases and counting. For example, if you just bought something recently from Amazon, after you checked out, and you're ready to, you hit submit or check out, paid for it, and it gives you a confirmation number, you'll see at the bottom that Amazon actually, the system, the software, provides you with a whole bunch of related products, because they have done their analysis and know that the people who just bought the item you just bought are more likely, very likely to purchase those items they recommended. So they can increase their sales and they help you make purchases on things that you also might find useful. Healthcare. For example, we all know healthcare, the cost is an issue, right? How long do you keep your patient in the hospital, right? And you can use stats to evaluate, for example, 100 incoming patients using a 42-item physical and mental assessment questionnaire. And use that to evaluate your patients and determine the appropriate type of care provided to them. Okay? Using quality control, you can initiate the triple inspection program, setting penalties for workers who produce poor quality output. That way, you ensure that you maintain high quality for your product. Purchasing, you can use stats to determine the defect rate of a shipment and whether that the rate has changed significantly over time. And then you use stat to determine whether in medicine, to determine whether a new drug is really better than the placebo, or if the difference is due to chance. Okay? Forecasting. You can manage your inventory by forecasting consumer demand. For example, for most retailers, half of their annual revenue is from the last 3 months of the year. That's the holiday season. Right? You need to have your enough or adequate inventory in order to meet the demands of the buyers. Right? So how do you manage that inventory? You need to do your forecasting and to make sure you have not just enough and not too much inventory. Product warranties. Use stat to determine the average dollar cost of engine warranty claims a new hybrid engine. You can use that to save money, okay, and increase efficiency. Okay. There are challenges in stats. An ideal data analyst, such as you guys, should be technically current. That is, how to use software, and you can communicate well with others both in the written and oral communications. Is proactive, right, and has a broad outlook of the situations, and is flexible, focus on the main problems and can solve the problems. Also, you are able to meet the deadlines because there are lots of deadlines that you must meet in order to make your work meaningful. You need to know your limitations and is willing to ask for help from other experts. You can deal with imperfect information. You cannot expect to always get perfect information. You have professional integrity. Be honest and truthful in what you do. Working with imperfect data. We have a data set that's imperfect. Right? You need to state any assumptions and limitations, and use generally accepted statistical tests to detect unusual data points or to deal with missing data. What do you do with those unusual data points? You can get rid of it, but only if it meets certain criteria, right? And dealing with the practical constraints, you will face constraints on the type and quality of data you can collect. You need to uphold ethical standards, know and follow accepted procedures, maintain data integrity, carry out accurate calculations, report procedures, protect the confidentiality of your client, and cite sources and financial support. And also, you may have to use consultants. Hire consultants at the beginning of the project when your team lacks certain skills or when unbiased or informed view is needed. In writing and presenting reports, you may want to use pictures and charts that can help you make the point. For example, this chart shows the recent GPA trends nationwide. And the three column groups are all schools, public schools, and private schools. And the y-axis here is average GPA from 2.6 to 3.0. And here, this legend here says the green is for academic year 1991-92, red 96-97, orange 2001 and 2002. So using this chart, we can see that for all schools in America, and for the three academic year period, the GPA is going up and is on the rise. That's good, right? And in public schools, it's also on the rise. In private schools, also on the rise. And but also we can notice that the private schools tend to have higher GPAs than public schools. That's using charts, bar charts in this case. Okay. Stats is useful for your critical thinking, and stat is an essential part of critical thinking because it allows us to test an idea against empirical evidence, not just something that you say, hey, I think so, or I feel so, my gut's telling me so. But you have solid data to prove that, right? Empirical data represent data collected through observation and experiments. Okay? There are pitfalls in using stats. Pitfall 1, making conclusion about a large population from a small sample. Right? You need to be careful about making generalizations from small group, for example, only 10 patients, to generalize that to the whole population. And second pitfall, making conclusions from non-random samples. Right? Be careful about making generalizations from retrospective studies of a special group, for example, heart attack patients. And it's not random samples, the conclusion may be mistaken. Pitfall 3, conclusions from rare events, such as the winning lottery. Be careful about drawing strong inferences from events that are not surprising when looking at the entire population. Pitfall number 4, using poor survey methods. Be careful about using poor sampling methods or vaguely worded questions. So, for example, anonymous survey or quiz. That's not good. Pitfall 5, assuming a causal link based on observations. Be careful. Right? Be careful about drawing conclusions when no cause and effect link exists. For example, most shark attacks occur between 12 p.m. and 2 p.m. Is that right? And it could be because actually, most people are swimming between 12 p.m. and 2 p.m. Therefore, more shark attacks, can possibly occur. So be careful in drawing a conclusion like that. Pitfall number 6, making generalizations about individuals from observations about groups. Avoid reading too much into statistical generalizations. For example, men are taller than women. Be careful with that. Pitfall number 7, unconscious bias. Right? Be careful about unconsciously or subtly allowing bias to color handling of data. For example, heart disease in men versus women. You may have unconscious bias, into that you don't even know. Excuse me. Pitfall number 8, significance versus importance. Statistically significant effects may lack practical importance. For example, Austrian military recruits born in the spring average 0.6 centimeters taller than those born in fall. That's not really, important. Also, the stats is actually an evolving field. It's a relatively young field and the discipline, and it has been developed mostly during the 20th century. Its mathematical frontiers continue to expand with the aid of computers of today. There are many major recent developments in statistics, including exploratory data analysis, EDA, computer-intensive statistics, design of experiments, robust product design, advanced Bayesian methods, graphical methods, and more. So you may encounter some of these, in the future in your work. Okay. Next, let's talk about the data and data collection. Right? If you feel like you can take a break and continue. Right? This is another chapter in your textbook. We'll talk about the definitions, level of measurements, time series versus cross-sectional data, sampling concepts, sampling methods, data sources, and survey research. Some definitions. What is data? What are data? What is data? Data are values of qualitative or quantitative variables. Could be both qualitative or quantitative. A data set is a particular collection of data values as a whole. Observation is each data value. It's an observation. Okay? The subject or individual is an item of study for study. For example, an employee in your company, a student in our class. That's a subject or individual. Okay? Variable is a characteristic about the subject or individual. For example, the employee's income, or the person's age, the person's height, etc. And for data, for the variables, number of variables involved and the typical text involved, we call the data set a univariate data set if there is only one variable. Okay? If one variable, we call it univariate data set. The tasks that we can perform with this kind of data set are histograms. We can construct histograms for one variable. Right? We can do descriptive stats and do frequency tallies, just count them. Right? If your data set has two variables, we call that the bivariate data set. With bivariate data set, we can do scatter plots, we can do correlations, and do regressions, simple regressions. Then if you have more than two variables, we call that data set multivariate. Right? We can conduct multiple regressions data mining, econometric modeling, etc., and many other good things. Okay? So to summarize that, the type of data we may have, we could have categorical data, that's qualitative, or we can have numerical data, that's quantitative. Right? So basically, there are two types of data. Right? So for categorical or qualitative data, for example, you can have the data with a verbal label. For example, the vehicle, type of vehicle. You can have X equals the different type of vehicle, car, truck, or SUV, right? Or gender of the group of people is a binary with only two outcomes, X equals male or female. Okay? And these are like the verbal labels for those categorical variables. But we can, for practical uses instead, we normally code it. Code data, for example, the vehicle type, we can use X equals 1, 2, 3 to denote car, truck, and SUV. So if in the survey the person has a car, we enter 1. You have a truck, we enter 2, SUV 3, etc. And for gender, since it's binary, we can use 0 and 1. 0 for male or 1 for female, or 1 for male, 0 for female, whatever. Okay? That's for categorical qualitative data. Right? For numerical or quantitative data, it could be discrete or it could be continuous. Right? A discrete number is like is whole number basically. For example, the number of broken eggs in a carton. You buy a carton of eggs. How many you have? You have a dozen eggs, right? How many do you have? Could you have that's broken in a carton? You could have no egg broken. You can have all 12 eggs broken. That's too bad, right? So the eggs could be anywhere from between 0 and 12. Okay? That's discrete because you cannot have 1.5 eggs broken. Basically, the egg either broken or not broken. Okay? And also the number of annual dental visits. Well, we don't really want to go see our dentist, right? But you may have to go. You could not go during the year. You can go once, twice, 3 times, for example. And these are all discrete variables, taking on only whole numbers. The data, numerical data or quantitative data, could be continuous, like that is with the decimal points or fractions. For example, the patient waiting time, the average is 14 minutes, 14.27 minutes. And that's a continuous number with a decimal point. Right? And also customer satisfaction rate, like 85.2%. That is continuous as well. Okay? There's the two types of data, categorical or numerical, qualitative or quantitative. Okay? And there are different level of measurements, right? Level measurement. We call that the nominal, ordinal, interval, or ratio. Okay? For nominal level measurement, they describe only categories. For example, the color of your eye. You could have blue eye, brown eye, green eye, or black eye. Okay? And that's different categories of colors. Okay? That's this first type or the lowest level of measurement. You measure categories. And then the second level, higher level measurement is ordinal. Right? In ordinal measurement, the rank has meaning. Right? For example, bond ratings. You have heard about the bond, the treasury bond, U.S. treasury bond, treasury bills, or a corporate bond. And the bond has ratings. Each company has its own ratings. It could be AAA rating, that's the highest. It could be AAB or C or D or F. And then there's a junk bond. You don't want to buy it. Okay. The different bond ratings, and there are categories, all right? There are different categories of bonds with their different ratings, but also the ranking. We know AAA bond is better than AAB, etc. Okay? Even higher level of measurement is called interval. Right? In this case, the distance has meaning. Right? And for example, temperature. A good example of interval measurement is temperature. 57 degrees Celsius. Right? And the highest level measurement is called a ratio measurement. That's where the meaningful zero exists. In interval measurement, meaningful zero does not exist. For example, a zero temperature, 0 degree temperature is just arbitrarily set. For example, we know a 0 degree temperature in Celsius is 0 degree. Is water's freezing point, and the same level of temperature in Fahrenheit is 22. So, and yet there are different other ways of measuring temperatures. Okay? So, but for racial measurement, though, a meaningful zero exists. The zero is meaningful. Right? And for example, accounts payable, there's a dollar amount, $21.7 million in accounts payable, or $0 in accounts payable. Okay? There's different levels of measurement. Okay? Again, to refresh, recoup, nominal level measurement, merely identify a category, right? Nominal data are qualitative, attribute, categorical, or classification data, and can be coded numerically. For example, the type of computer you have. Again, we use 1 for Apple, 2 for Compaq, 3 for Dell, and 4 for HP. Right? And only mathematical operations are counting and tallying. That is count frequencies and do some simple statistics for nominal measurement. For ordinal measurement, ordinal data codes can be ranked. For example, the Likert type scales that we use in surveys, 1 for frequently, 2 for sometimes, 3 for rarely, 4 for never. That's a rank order, showing the different level of possibilities or preferences. In ordinal measurement, distances between codes is not meaningful. Okay? For example, the distance between 1 and 2, or between 2 and 3, or 3 and 4 lacks meaning. Okay? But many useful statistics tests exist for ordinal data, especially useful in social science, marketing, and human resource research. Next one, for interval measurement. Data can not only be ranked but also have meaningful intervals between the scale points. For example, the difference between 60 degree Fahrenheit and 70 degree Fahrenheit is the same. 10 degree difference is the same as the difference between 20 degree Fahrenheit and 30 degree Fahrenheit. So there's meaningful intervals. Okay? For interval measurement, since intervals between numbers represent distances, mathematical operations can be performed, like average. We can call it average. But 0 point, as I said, 0 point of interval scale is arbitrary, so the ratios are not meaningful. You cannot say like 60 degree Fahrenheit, is twice as warm as 30 degrees. You cannot say that. Okay? Finally, the ratio measurement. The ratio data have all the properties of nominal, ordinal, and interval data types, and also possess a meaningful zero. That is the absence of quantity being measured. Okay? Zero quantity. For ratio measurement, because of this 0 point, ratios of data values are meaningful. For example, $20 million profit is twice as much as $10 million profit. Okay? 0 does not have to be observable in the data. It is an absolute reference point. Likert scale, that's something that's used very often in statistics, in research, business research, and social research. Right? That's a special case of interval data, frequently used. Right? The coarseness of a Likert scale refers to the number of scale points. Normally we have 5 or 7. Of course, you can have as many as 9 or as few as 3, but 3 is probably not that descriptive. Normally 5 or 7 are used. If you use 5, you have 2 on either side and 1 in the middle. And 7, you have 3 on either side and then 1 in the middle. Okay. Like this one, for example. College bound, the question here is, college bound high school students should be required to study a foreign language. Do you agree or not agree? Right? You can ask the respondent to check one. Right? The one in the middle here is neither agree or nor disagree. Right? That's neutral. And there's a strongly agree, somewhat agree, somewhat disagree, and strongly disagree. Right. So this is in this Likert scale. It shows people's agreement or disagreement with the statement. Next one. This one is symmetrical. You can see that, right? The two on this side and two on this side. Okay. But it doesn't have to be. How would you read your English instructor? Check one. Right. You can say that he's terrible, he's poor, he's adequate, he's good, or excellent. Right. It's not symmetrical. Right. These both are Likert scales, Likert type scales. Right. How to determine the level of measurement? You can use the following procedure to recognize data types. I'm going to give you will be working on your problem set assignments. That's your assignments, the group assignments. You can work on problem set together. There will be questions like that. How do you identify the level of measurement? I want you to use this procedure. Okay? Use this procedure. First, you ask yourself a question. The first question: is there a meaningful zero? Right? If there is, if yes, it's racial data. And end of question. It's simple. Right? You can perform all statistical operations, on that type of data. And if there is no meaningful zero, you ask the second question, Q2. Are intervals between scale points meaningful? Right? If it's meaningful, then it's interval data. Okay? You can do common statistics such as means, standard deviations. We'll talk about those later. Okay? And then if not, then you ask your third question. Do scale points represent rankings? If they do, it's ordinal data. It's restricted to certain types of non-parametric statistical tests. Right? If they do not represent rankings, then you ask yourself the last question: are there discrete categories? Normally, yes, they are. Right? They are discrete categories, and then it's nominal data. Okay? Only thing you can do is counting. Finding the mode, and count the tally, count frequencies. Okay, this is what you do to determine the level of measurement. Changing data by recoding. Sometimes we may want to recode data. In order to simplify data, or when exact data magnitude is of little interest, racial data can be recoded downward into ordinal or nominal measurements, but not conversely. You can only go down, not go up. Okay? For example, you can recode the systolic blood pressure as normal, is under 130, or elevated between 130 and 140, or high blood pressure is over 140. So basically, you can go with the racial type of data into categorical data. Okay. The above recorded data are ordinal, and ranking is preserved, but the intervals are unequal, and some information is lost. Right? So that's recoding of changing data type. Time series versus cross-sectional data. You need to be careful when you have a data set. You need to ask yourself, is this time series data, or is it cross-sectional data? Okay. What is time series data? Basically, for time series data, each observation in the sample represents a different equally spaced point in time. For example, years, months, or days. Okay. And periodicity may be annual, quarterly, monthly, weekly, daily, hourly, etc. Okay. In this case, we are interested in the trends and patterns over time. For example, annual growth rate in consumer debit card use from 2001 to 2008. So we want to see the pattern over this 7 or 8 year period. Okay? And that is time series data. Okay? Data are collected over time. Okay? For cross-sectional data, it's different. Right? Cross-sectional data for each observation represents a different individual unit. For example, a person at the same point in time. Okay? For example, monthly Visa card balances. Right? For all the people, all the individual persons, all the people at same point. For example, last month, we look at all the persons, old people's, credit card, Visa card balances, monthly balances at the end of last month. Right? That's cross-sectional data. Okay? In this case, we're not interested in the variation of data over time, but rather we're interested in variation among observations or in relationship. You see which type of people, what type of people are having a higher balances versus the lower balances. Okay? We can combine the two types of data to get the pooled cross-sectional and time series data, if you need. Okay? Another thing about the next, let's talk about the sampling issues. How to get samples, sampling some concepts and samples. Right? So, what is sample and what is census? Basically, a sample involves looking only at some items selected from the population, and the census is examination of all items in a defined population. Right? Why, for example, why can't the United States Census survey why can't the U.S. Census survey every person in the population? Right? You may ask that question. Okay? And basically, sometimes they try hard to get everybody to answer, but still they may not get everybody to answer. Okay? And some, for example, some illegal immigrants, right? Even though even though they're illegal, but they should still be counted. That's required by Constitution, but they may not want to be interviewed or counted. Okay? It could be budget constraints, could be incomplete responses or non-responses. Therefore, we may not have. But pretty good overall. The U.S. Census data is pretty complete and accurate, and it's done every 10 years, and then every year they do a sample survey. Okay? Situations where a sample or census may be preferred. Not always. You don't always, or cannot possibly always have a census, right? And you may have to use the sample. Right? When do you use sample? If you face an infinite population, apparently you cannot survey everybody. You have to use sample. You have a destructive testing for quality control, for example. You want to test to see, for example, the Dunkin' Donuts, or Krispy Kreme donuts rolling out of the machine. You want to see if they're good. They taste right? But if you taste it, you eat it, then the product is gone. So for destructive testing, you cannot test all the donuts. If you eat all the donuts, you have nothing to sell. So you can only take sample. Right? Sometimes for timely results, you have to do a sample. For accuracy, sample is pretty good actually in accuracy. Cost issue. Or when the information is sensitive, you have to use sample. Okay? When do you use census? If you have a small population, you can possibly use census. Right? If you have a large sample size, you can use census. If there's the database exists, you can use census. Or it's required by law, like U.S. government, they have to use census. Okay? Also, so what is statistics? Statistics are, computed from a sample of n items, those lowercase n items, chosen from a population of n samples. Right? And we have parameters and we have statistics. Basically, if this one here, this is the population with a number of n items, capital N items, and then we take a sample from this population, like a small portion from that, and that's your sample with the little n. The number of items is little n, smaller n, right? So, and the samples, statistics are computed from a sample of n items chosen from population of capital N items. And statistics can be used as estimates of parameters found in population. So we use sample, we take a sample from the population, right? We calculate the mean, we calculate the proportions, and we use that to represent the population parameters. Okay? To notice there's the terminology here, the letters we use. For population parameters, we use mu here, Greek letter mu for population mean. We can use pi for population proportion. For sample, we use x bar for sample mean, and we use p for sample proportion. Right? The rule of thumb here is a population may be treated as infinite when n is at least 20 times the small n. So then we can say it's infinite. Okay? And different symbols used. Okay? We're going to use that, adhere to that nomenclature in this class. Okay? Target population. What's target population? The population must be carefully specified, and the sample must be drawn scientifically so that the sample is representative. That's your target population. The target population is a population we're interested in, surveying or studying. For example, the U.S. gasoline prices, one study. Okay? The sampling frame, another term called sampling frame, is a group from which we take the samples. Okay? But to get the gas prices in the U.S., what do you do? Right? You go, you survey, you take a sample of 115,000 stations, out of maybe hundreds of thousands or millions of stations nationwide. We use that 115,000 stations. Use the price from those stations, to estimate the oil gas prices in the country. Okay. The frame should not differ from target population, naturally. Okay. Sampling methods. There are different ways for us to get samples. Right? There are different techniques, different samples. First, probability samples. What are probability samples? Those are the sampling techniques such as random sample, systematic sample, stratified sample, and cluster sample. These are all probability samples. Okay? First one, single random sample. This is how do you get that sample? Basically, you need to use a random number generator to select from a list, like Visa card holders. You get a list of all the Visa card holders. You use random. You number them. You number them from 1 to say 2,000, and then you use a random number generator to determine which one to select. That will be a simple random sample. Okay. A systematic sample is one where you select every case item from a list or a sequence. For example, restaurant customers. You wait at the door, you count, you ask every fifth customer coming in or going out and ask them to help with the survey. And that would be a systematic sample. Okay. A stratified sample is one where you select randomly within a defined strata. That is, for example, by age, occupation, and gender. The different strata. Within each stratum, you do a random selection. A cluster sample is one where, like a stratified sampling, except the strata are geographical areas. So, for example, a zip code. Okay? But these four are all probability samples. But there are also non-probability samples, like judgment sample. With a judgment sample, you use expert knowledge to choose the typical items. For example, which employees to interview. And they use the expert knowledge to do that, to decide on that. It's on the random process. It's not non-probability sample. We can use convenience sample. Use a sample that happens to be available. For example, ask your co-workers their opinion at lunch. If I want to do a survey, I use you guys, my MBA students, to answer my questionnaire. You are my convenience sample. Okay? You can use focus group. You can use in-depth dialogue with the representative panel of individuals. For example, some iPod users as a focus group. You get opinion from them. That's a non-probability sample. Okay? When you do sample, there's an issue of with or without replacement, meaning that if we allow duplicates when sampling, then we are sampling with replacement. Duplicates are unlikely when n is much smaller than the large n, capital N. Right? If we do not allow duplicates when sampling, then we are sampling without replacement. so it's with or without replacement. Sampling methods that in Excel, you can do, like, for example, to get generate a random number in Excel. You can do this. You can practice at home on your computer. You can enter an Excel function equal rand between 1 and 875 into 10 spreadsheet cells, and then you press F9, then you get a new sample every time. The number will be random, will be between 1 and 875. Okay. In Excel, you can also enter the function equal int 1 plus 875 times rand, and to get the numbers. If you go to use internet, you can go to website random.org. It'll give you many kinds of excellent random numbers. Use Minitab, which we don't use in this class. You can use Minitab to get random numbers as well. Okay, so different ways of doing that. So, but you need to be careful. These are actually pseudo-random generators, because even the best algorithm eventually repeat themselves, right? But the chance is very low though. Okay. Systematic sampling. That's a sample by choosing every case item from the list, starting from the randomly chosen entry on the list. For example, starting at number 2, we sample every fourth item to obtain a sample of 20 from a list of 78. So this is a list of 78, right? We say we start at number 2 right here, this one here, and we sample every fourth item. So from here, starting with this one, we count 1, 2, 3, 4. We sample this one, and then 1, 2, 3, 4. We sample this one. 1, 2, 3, 4. Another one. We keep going until we get a 20. So this will be a systematic sample. Okay. And stratified sample, you can utilize prior information about population. It's applicable when the population can be divided into relatively homogeneous subgroups or known size. That's called a strata. Okay? A simple random sample of the desired size is taken within each stratum. Okay? That's stratified sample. For example, from a population containing 55% male and 45% female, we can randomly sample from 110 males and 90 females for a total of 200. And that represent the proportion of men and women in that group. Okay. Cluster sample is a stratified sample also, but the strata consist of geographical regions. You can do a one-stage cluster sampling or two-stage cluster sampling. When one-stage cluster sampling sample consists of all elements in each of the k randomly chosen subregions or clusters. In two-stage cluster sampling, first we choose k subregions, some clusters, and then choose a random sample of elements within each cluster. So that's two-stage. Okay. Here's an example of two-stage. Right? Example: 4 elements sampled from each of 3 randomly chosen clusters. Right. First, this is the total area. Like say the counties in the state, for example. Right. We choose 3 randomly chosen clusters, the yellow one, highlighted yellow ones. Right. The 3 clusters. Within each cluster, we randomly choose 4 elements. Right. And then that's our sample. So this will be a two-stage cluster sample. Okay. Judgment sample is a non-probability sampling method that rely on the expertise of the sampler to choose items that are representative of the population. It can be affected by the subconscious bias, non-randomness in the choice. Okay. And quota sample is a special kind of judgment sampling, which the interviewer chooses a certain number of people in each category, so using a quota. Okay. Convenience sample, take advantage of whatever sample is available at the moment. It's a quick way to sample. Right? Focus group, a panel of individuals chosen to be representing for a wider population, formed for open-ended discussions and idea gatherings. Focus group. Right? Source of data. You guys are going to work on your group project. I need you to read your syllabus carefully, and I need you to find the data set. And you can also go to these data sources to find the data. Right? One goal of a statistics course is to help you learn where to find data that might be needed. Fortunately, many excellent sources are widely available. Some sources are given in the following table, like U.S. general data, U.S. economic data, almanacs, periodicals, and indexes, databases, world data, web data, right? Like general data like statistical abstract of the United States, economic report of the president, right? World almanac, time almanac, Economist, Businessweek, Fortune magazines, they have lots of data. New York Times, Wall Street journals, right? CompuStat, Citybase, and U.S. Census are big, good databases you can use. CIA World Factbook is a really good, excellent source for data, numbers, facts about different countries of the world. Right? On the web, you can use Google, Yahoo, or MSN to search engines to find data. Also, you can find data from your own company, the company you're working for, or institutions, organizations, but make sure you get the approval for use. You may have to disguise some or just cover some of the sensitive information before using that. Okay? Now let's talk about the survey research. Right? How to conduct survey research. There are basic 4 steps of doing research, survey research. Step 1, you need to state the goal of the research. Step 2, develop the budget, time, money, and staff. And step 3, create the research design. The target population, frame, sample size. Step 4, choose the survey type and method of administration. Okay. And step 5, design the data collection instrument, that is questionnaire. Right. And step 6, you pre-test the survey instrument and revise as needed. And step 7, you administer the survey, do follow-up if needed. Step 8, you code. Once you collect back the survey, you have the survey results, you code the data and analyze it. Okay? The type of survey you can have, you can use mail surveys. You can mail the questionnaire to potential respondents, ask them to fill it up and send mail back to you. Of course, it's very costly to do that. Right? Telephone surveys, you can call, get a whole bunch of numbers and call those people to ask them to fill out your questionnaire. Okay? And you can conduct interviews to do survey. You can put your survey questionnaire on the web and get people to answer that. You can use direct observations if necessary. Okay? Some guidelines about survey. There's a planning. You need to carefully plan it. Design well and make sure quality is there. And you may have to do some pilot tests to test your questionnaire. And you may have to buy in. And you can use a lot of expertise to do that. In design your questionnaire, be careful that you need to use a lot of white space in layout. Right? And you begin with a short, clear instruction telling them how they're supposed to fill in the questionnaire spaces, blanks. Right? You need to state the survey purpose, assure them anonymity. No personal information will be revealed. You collecting aggregate results, okay? And instruct on how to submit the completed survey. Okay? And you should break survey into naturally occurring select sections, right? And you should let respondents bypass sections that are not applicable. For example, if you answer no to question number 7, skip directly to question 15, so they don't have to go over questions 8 through 14. Okay? You need pre-test and revise as needed. As I said, keep it as short as possible. People are busy; they don't want to spend too much time on that. Okay? The type of questions you can ask in survey could be open-ended questions. Ask them to just answer freely. You can ask them to fill in the blank. Right? You can ask them to check boxes. That's very often. You can ask them the rank choices, put in ranking order. You can use the pictograms, and you can use the Likert scales. Okay. Question wording. The way a question is asked has a profound influence on the response. Let me give you an example here. Right? If you ask them, lots of people, shall state tax be cut? How will people answer? Most people will say, hell, oh yes, let's cut taxes. Okay? So you get a lot of negative responses to the question. Right? Now, if you ask a question, shall state taxes be cut? If it means reducing highway maintenance, and then people were thinking about the potholes or the despair of our highways, and then they'll think again about whether they should support the cutting state taxes. Right? Now, if you ask a question like this, shall state tax be cut? If it means firing teachers and police, and then you really get people thinking, whether you should the state tax should be cut. So you see the same question asked a different way, different ways, you will get a different type of responses. Be careful in the wording of the question. Okay? And make sure you have covered all the possibilities. For example, are you married? Say yes or no. Right? What if this person is widowed? The widower, widowed. How do you do that? How should they answer? Okay? And also, you should make sure that the overlapping classes or unclear categories are not there. For example, in this one here, how old is your father? You're given the 35 to 45, 45 to 55, 55 to 65, 65 and older. But one thing, if the person is 45, which category should the person check? This one or this one? So that's not good, right? There's overlapping classes. And also, what if the father is under 35? So it's incomplete. Right? So be careful when setting up the classes or categories. Okay? Responses are now next about the coding and the data screening. Responses are usually coded numerically. For example, we use 1 for male, 2 for female, and then what about missing values? If you have missing values, typically denoted by a special character like blank or something asteroid. Okay? And you can discard questionnaire that are flawed or missing many responses. You cannot use that. You need to watch for multiple responses, outrageous or inconsistent replies, or range answers. Okay? And you need to follow up if necessary and always document your data coding decisions.